Hello, my name's Bob Willis and welcome to Defect of the Month, brought to you by the NPL Defect database. Now, the NPL Defect database is basically a collection of photographs of different types of defects that we've seen in the industry, and we try to give you examples or reasons why particular defects have occurred and hopefully some corrective action. It's been running for a few years now, and we're always interested in people adding more material to the defect database. Now, poor hole fill on printed circuit boards can be caused by a number of things. Now, if we're talking about the wave soldering process, it can be poor flux application, so flux into the plated through holes penetrating up to assist the soldering operation. It can be the incorrect preheat temperature, so the board needs to get up to sufficient temperature so when it makes contact with the solder wave, there is obviously capillary action, there is extra heat from the solder wave, but if there isn't sufficient heat in the core of the printed circuit board, then poor hole fill will result. Poor hole fill can also be affected by the design of the printed circuit board, particularly on a multi-layer. As the number of layers builds up in a printed circuit board, that's effectively more metal. So we need to make sure the core of the board and also the top side temperature gets up to sufficient temperature to allow soldering to take place. Now, to improve the design, what we can do is reduce the number of interconnections from the through hole to the inner layers. Now, by reducing the number of connections, now typically on an interconnection on an earth plane you may have 4, we could reduce that to 2. Or we could remain and have 4, but actually reduce the thickness of the interconnection from the plated through hole to the core layer. Another trick of the trade is increasing the insulation gap between the plated through hole and the copper layer in the inside of the printed circuit board. All of those things reduce the heat being taken away during the soldering operation. Now, all of that is also true for selective soldering. Now, if we still have poor hole fill during automated soldering, it may well be down to perhaps solderability of the printed circuit board, but that should be quite evident if you do simple checks or look at the board after the reflow process if you're doing a double stage assembly. Finally, it's possible that we may have poor plating in the printed circuit board. So if we've got lots of voids, if we've got poor copper fill of the plated through hole, then we should be able to visually see that fairly easily with a kaleidoscope inspection system, one of these handheld pocket inspection loops. So again, those are some of the reasons why for automated soldering we can have poor hole fill.